let's jump directly. No logistics today. Let's jump directly into the discussion. Okay. Let me know if you guys can see my screen and also see me. Can you see me?
Yep. Yes, and yeah, it's got that screen as well.
Okay, perfect. All right. Let's see. And we learned quite a few things, right? I just wanted to bring the closure to this adjacent technology today. So we went through understanding the basics of wireless, wireline, wireless, and we learned about standards and then open sources. And now we are in the process of learning about adjacent technologies, which we will try to close it today. And finally, we will close this session with the spectrum, right? And a quick survey we will do, right? To kind of understand from your perspective, because you have been attending quite regularly, right? This is good. So let me jump directly into the technology session. So in the technology session, what we really did was how all these different products are getting developed, product platforms, services and solutions, and how different technologies comes together and plays a huge role, right? Whether you're calling it as an industry 4.0, web 3.0, business 2.0, whatever, right? That's what it is. And we kind of started understanding the most important technology, which is the foundation of number of things, right? From cloud, what is the difference between the cloud and SDN and NFV? That's what we kind of understood. We learned together on multiple ways. And in our previous session as well, we went into the understanding of NFV architecture, and we kind of understood what are all the different blocks, how all these different things comes together, and the whole system works, right? That's what we kind of learned in our last session. And then what we did was we got into the summary of it, right? We kind of learned the whole thing, and then we got into the summary of it. Let me quickly say here. So in the summary, what we were talking about is mostly focusing on the right hand side, right? So in the left hand side, we know there is an hardware. There is a something sits on top of the hardware that abstracts the hardware, that is called as an hypervisor, and provides you with the virtual compute, storage, and network resources. And you take those virtual compute, storage, and network resources, you form a virtual machine or a containers, and inside that you actually install your actual network functions, right? Now the network functions at this level, what you get is the virtual machine, right? In the virtualized infrastructure level, you get the virtual machine. Now, or the container. In this, I have put an example of virtual machine. Now, what you can do is you can use one virtual machine, you can put one network function, or you can split the network functions into a microservice architecture, and you can put 3 or 4 different microservices within 3 or 4 different VMs, and all these 4 VMs can together function as a network function, right? So that's what the virtual network function is all about, that layer, and this whole thing is managed by the VNF manager. And then when you go into the top, this is the master manager. It's called as a service orchestrator or resource orchestrator. What it does is it manages the complete life cycle of all the VNFs connected together as a network service and the different functionalities around that, right? So from bottoms to top up, the management goes adds up. So when you come to this level, it's mostly an abstract level, right? The next level you go a little bit more details at the VNF level. Next level you go a little bit more details on the virtualized infrastructure level, right? So this is very important to understand. And in every level, right? Here in this level, you have a VM, next level, you have VNF, and in the top level, you manage the network service. And every level that you manage, there are different procedures that you need to do. And these are all the procedures. Normally, you write it as a code when you are building the different management layers, right? So that's what it is all about at a very high level. Now, what's also very important, we kind of talked about this, is to understand if you wanted to make this whole thing work, right? Everything requires an input. Then you do some business logic and then you provide an output, right? And now AI, obviously, it's a little bit different, which we'll talk about. So when there is an input, there is a business logic and there is an output. So what is the input for all these different automations and orchestrations and lifecycle assurance, whatever that we talk about, right? What is the input is some documents, right? We call it as a templates. In theoretically, at a concept level, we call it as a descriptors. Okay, so these are all the descriptors or the input files to these different business logics. So the business logics can actually do the work of all these different procedures. Okay, so you have number of different types of templates that are defined. We call it as sometimes heat template. There's something called as that. What is that? What is that? Yokesh, the DevOps guys know, right? You have a heat template for OpenStack. Then you have there are different types of templates that you say in containers. There is a name for the container templates. Tofka. What is that? Anyone can assist me here? In containers, you have these templates. What's called?
Helm charts or
Helm charts, heat template.
Terraforms.
Yeah, so there are multiple templates that are available, right? Those are the names given to those specific open sources. But if you wanted to understand the concept, if you go to the standards, those things, these are all the templates that define. If you wanted to manage the physical network function, they have defined a template, and if you comply to this template, all other systems should understand. Same thing for VNF. Same thing for virtual link. How different VM links are connected, VNF links are connected, how different VNFs are connected. Right? First one is the actual links, IOs, then how the VNFs are connected, and how all the VNF forwarding graph in the next level is connected as a network service, right? So these are all the different templates. Now these templates could be a Helm chart, heat templates, or whatnot, right? But these are all the syntax that is provided. But most important thing is this is the input to your business logic where your orchestration, automation, lifecycle management does its own job, right? Allocating the resources, opening the VM, and installing the VNF, creating the network service, everything happens. Then once that's the instantiation, right? Onboarding time. Once the onboarding happens, as you know, the beauty of cloud and NFV is it can scale up, scale down, all these different things that can happen, the features that we talked about, right? Portability, moving from one place to another place. That means dynamically a lot of things happen. That means when it is up and running, this template may not be applicable anymore, right? So what happens is because it keeps changing, these templates has to be automatically updated. So in real time, it gets updated. And in the concept wise, it's called as an NSR. Same thing, right? Network service resource. In this case, network service descriptor, right? So this is the document that gives you at a given point of time, the templates that gives you at a given point of time, what is the current network topology is. Okay. So these are the key concepts that you need to understand. Then you can always map it to the respective stacks that you're using and respective templates that you're using. So whatever that I explained here is kind of in this one, right? You have network functions, you have an endpoints, you connect all these network functions. It's called as a network function forwarding graph, which is your, a VNFGD, right? Then after that, you have on top of that end-to-end network service, right? So this is what it is. And sometimes they refer a word called service chain, but end of the day, it's all the same. How this whole service, like voice service, is provided using all these different VNFs is nothing but a service chain. This is the service chain for voice service, which has eNodeBs to different ORAN components to core components to actual PLM and components, right? The whole thing is your service chain, which provides a broadband service or a voice service or IoT service, right? So that's how it's always conceptually looked at. So far, so good, guys. Is it clear?
Yes, Kader.
Yes.
Nice. Now, what is more important is, see, we talked about cloud, we talked about NFV, we talked about number of things, right? SDN. But these are all the data centers. In reality, these are all the data centers with a lot of hardwares that are sitting in different places, whether it is regional, local, closer to user, it doesn't matter, right? So now what happened is because of a lot of new applications that are coming up, you actually need two things, right? First thing is you need most of the processing happening at the edge. Okay, so if you put the data center closer to the user, it becomes the edge data center, it becomes the edge computing. Okay, sometimes you also do it at the fog level, right? And device level. So there are certain business logic you can run at the device level, closer to the device level, and closer to the multiple user level, right? So there's not different places that you put and different names that is given. But most important concept that you need to understand is because of a lot of applications require low latency based responses, right? You need to have a lot of processing happening closer to the user. Now, if you bring the data center closer to the user, it becomes an edge data center. It's called as edge computing. But the functionality of managing the data centers is same as managing the data centers in central or in regional. Okay. But only difference is the management of the edge computing has to be a little bit lightweight, right? You can't have the heavy weight of management how you do it in the central. So what happened was the people started, kind of slimming it down the operations that you do. Operations are the same. Lifecycle management, whatever you see here, pretty much whatever you see here, everything you have to do it in the edge, right? Otherwise, you won't be able to do things, right? But what they did was they slimmed down the complexity and they tried to create a slimmer version of all this automation and orchestration. So it's not too complex. So you can install your applications, even web applications, SDN applications, or even the network applications at the edge. Okay, and there is a standard body called ETSI, right? You all know, and they define this edge computing related standards. But the most important thing here is one is bringing the data center close to the user and doing it. There is another thing, right? Intelligently doing it. That's the second key point most of the people miss, right? So the edge computing, the mobile edge computing or multi-access edge computing that is defined by ETSI allows you not only to bring the data center close at the edge, but also do things intelligently. It means it defines lots of APIs, right? And you can use that APIs and get the information from the access. I'll give you an example so it will become easy for you to understand. I wanted to stream a video and I need a bandwidth of, let's say, at least 4 Mbps, right? Because there are so many users are there, right? Whatnot, for understanding, let's say 4 Mbps is what that I need for whatever the application that's running in the edge to stream something to the end user. Now, what it can do is it can go to the eNodeB and it can ask how much bandwidth do you have that you can stream to the user. Then eNodeB will come back and tell to the edge saying that, hey, I have only 2 Mbps, not 4, what you are asking. Then what you can do is you can reduce the codec size, use a different codec size, reduce the number of throughput that you wanted to send, and then you can send it within 2 Gbps, right? So this is what I mean by intelligence. So what they also define is they define a list of APIs to understand basically to understand what the access capabilities are, and also the real time what access is actually delivering for you for operation and maintenance purpose. And then based on that, the application sitting in MEC can do its job. So these are the two key things in the edge computing you need to remember. Most of the guys only remember the first one, right? The first one is, okay, it's closer to the edge. If I run the application, it will be faster. The second one is the intelligence part where you can get the details about the access a lot of people miss. And that's also a very, very key thing. And if you wanted to really understand that, right, what you can do is you can actually go to ETSI MEC. Right? This is the multi-access edge computing. You can actually go here. Wow, it's interestingly slow. Can you guys hear me okay, right?
Yes, Kada.
Yes.
Yes, Father. So if you go here, there is MEC APIs, right? So if you click this, it will take you to the 4jhc.org. If you go here, there are APIs defined for multiple things, but what we are talking about is multi-access edge computing. So there are multiple things, right? The location API says your application can call some of the APIs, location APIs in eNodeBs to get the user locations. And then based on that, you can provide location-based services, right? So like that, there's a number of things that are defined, right? Vehicle to X information service API to understand where the vehicles are there. So it will make actually your application smarter if you try to communicate with the access to understand, depending upon your business logic, what you need to understand and do your application. This is the second key part in, especially in the mobile infrastructure, the intelligence part in the mobile infrastructure. Okay, so far so good, guys.
Yes,
All right. Okay, so Yokesh, what I'm going to do is I'm just going to go through this flow to close this, and we will see if we have a time for the other one, right? And then we will accordingly decide, okay? Because I just want to make sure this is a clean flow, right? I want to go through this. It'll be interesting to get this to a closure. So now let's move on. So the next thing that I wanted to share with you is, so far we have understood everything, right? But I wanted to kind of bring a different thought process into your thinking, right? Like I mentioned I've said this in multiple times, the barrier to the entry of understanding these complex technologies is zero right now, right? Take Bhavin, for example, then there are so many small service providers are available right now around the globe. It is impossible for them to be in existence if that openness and the barrier to entry is blocked, right? And the barrier to entry is opened mainly because of the open source that are out there. Otherwise, it used to be a very, very expensive affair for anyone to become a service provider. It's not an easy thing to do. Okay. And on the website, you have technologies like WebRTC that allow you to become a service provider as well, right? Just using the web technologies, you don't need any other technologies, right? As long as you are wired in the wired area, right? So anyways, so the open source played a very, very important role to enable innovation. And this is one of the blueprint of Linux Foundation, where different open sources that are coming together to kind of deploy whatever that we have discussed in a more practical way. Okay, so whatever we discussed, the concepts that we have discussed, these are all the different open sources that sits in different places to make this end-to-end thing happen. Okay, and what I wanted to really do in this is spend 10 minutes to really understand what are all these open sources. And if you understand these open sources, whatever the concept that you learned before to this concept, you will be able to map it, right? So that's the thought process. So what I'm going to do is I'm going to copy this link. Open it here. Okay, so this is what it is. Now let's start with what we have so far learned is the Magma, right? Magma is nothing but an application layer converged core network that supports 4G and 5G core network, right? That's what it is, and it also supports Wi-Fi, but it's mostly a converged core network. This is something that we have already learned, right? Now, if you go down towards the, I want to go down towards the left, right, on the top layer, right? You have a core network, then you need a radio, right? So now let's go to the radio, ORAN. So ORAN is an organization that basically defines RAN that is open, right? Before, all the radios used to be closed, right? Now it's all open and disaggregated. And I will connect this disaggregated one to decentralized one in the subsequent slides. But the idea here is that if you look at historically, when we went through 1G to the 5G evolution, we went centralized, then we went decentralized. We went centralized, then we went decentralized. Now we are all becoming decentralized, mainly because of Web 3.0 evolution. I'll talk about it in the subsequent slide, right? But the decentralized is really good. It increases the complexity in management. Okay. But at the same time, it gives you the flexibility to deploy the way that you want to deploy, depending upon your use cases. In olden days, why from decentralized we went to centralized is mainly because at that time, the technologies were not available for you to automate those things. Now, there are a lot of technologies that are available right now from AI to number of things that can help you to automate the complexity that are introduced by the decentralization. So that is why we are again going back to the decentralization to take the full benefit of decentralized way of deploying the networks depending upon different use cases that you handle, right? So the O-RAN is a very good example of a decentralization of the radio network, splitting different components, L1, L2, L3, L4, right, into different components, into different splits to create the disaggregated radio network. Now, I'm not going to get into the details of the radio network. Why? Because we have already learned that in our previous session, right? We looked at different splits of O-RAN, but this is an open source, again, that reduces the barrier, right? So you have your core network, you have your radio network, okay? Now what we are going to do is, these are all your VNFs, right? And then network services on top of that in the previous slides that we learned. Now what we are going to do is we are going to go down, right? The hardware and the management layer. Now, what I explained to you guys is, see, there is a data center somewhere in the central, there is a data center somewhere closer to the users and even more closer to the users. Sometimes it's called as a fog computing. This number of names are given, right? Leave the names out, but just consider that there is some data center which is far away, a little closer and more closer, right? Now, in order for you to do all these things, you need some kind of management, right, at these layers, and then you need some kind of a management for all these layers that cuts across horizontally, right? So that's what I explained in the previous session. Now let's look at that from this architecture point of view. Let's start with the device edge, right? You have an edge stack, smart edge, device edge. Let's look at the device edge, right? Zeppler. Go back here, go back here, go back here. Okay, so what is this? It's again an open source, right? That basically allows you to, it's a real-time operating system, right? That allows you to make your devices more secure. It's an open source. It's a real-time operating system for the devices to limit, with very limited memory and processing capabilities, right? So before if someone wants to do this, you have to buy from some vendor who offers the real-time operating system. Now you don't have to, right? It's because it's already available. And this particular real-time operating system supports all the protocols that you talked about, right? Whether level 2 protocols and level 3 protocols, right? From Bluetooth to the IPv6 to the LoRaWAN to the all the other protocols, right? That is required that you can actually use it at the device level. So that is your Zepper, okay? Now let's go one right. Then you have a smart edge, right? So in the smart edge, there is a fledge here. Let's go back to the fledge here. I'm purposely reading through this because I wanted you to connect this to the concept that I mentioned there, okay? So if you go to the fledge, so what is this? It is an industrialized edge focused. So if you are building an IoT based applications, right? And this Fledge is an open source framework that will provide you with a lot of abstraction to the details so that you can leverage this Fledge open source framework at the edge to do some industrial applications like predictive maintenance and so on, right? So if you look at industrial application, again, I don't know if you remember or not, in our presentation, we talked about, let me see if I can quickly give you guys, if I show you, you'll understand what I mean. We talked about this slide, right? So which is an industrial application where you have number of different applications that collects the sensors, collects the data, and these applications do its job, right? This is your industrial stuff. Now, if you go back here, okay, so the Fledge that sits at the smart edge will allow you to provide those in a more abstract way, right? Before you need to build by yourself or you have to go and buy it from someone, but this does that. If you see it, it is a framework for industrial edge, focused on industrial applications, critical applications, for use cases such as critical operations, predictive maintenance, situational awareness, and safety. It has its own integrated IoT technology, right? And it has intelligence about DCS, PLCs, SCADA systems. Okay, so that's the open source of Fledge. Now you can kind of understand why this Fledge is here. So I go back to sorry. Yeah. If I go back to this, right? Why Fledge is here? Because in industrial applications, the latency is very, very important, right? You need to manage them very critically. That's why it's very, very close, and they are putting it inside the smart edge. Okay, now let's go back to the next one here, edge virtualization. Okay, so now if you go down here, edge virtualization is Eve. And if you remember here in Fledge, we also said it works closely with Eve. Why? Because this is the upper layer, right? So there is something that has to deal with the hardwares and abstract the hardwares, right? So you need some kind of a layer, like how you have here in the centralized core, you need some kind of a layer at edge, which is a lightweight that can manage the servers, gateways, and devices at the smart edge, right? That's what is your edge virtualization. And that's what is your Eve, right? It's called as Eve. And if you go down and here, that's why they're saying the project Eve works together with Fledge, because it's the one layer down, right? But end of the day, it's like an hypervisor, right? But it does what is more applicable for edge. So if you look at this, edge virtualization platform for enterprise smart device edge outside of physical secure centralized data facility. Obvious, right? Based on what we discussed. Provides an open standard architecture with APIs for user to control and have visibility on on-premise device operations. Eve components include, end of the day, bottom line is hypervisor, so that it can manage the hardware at the smart edge. The Fledge may run on top of Eve, right? If I go back to this diagram, the Fledge can run on top of Eve, right? And then they also say Ajax Foundry. Ajax Foundry is similar to Fledge. You can have an Ajax Foundry that's kind of similar to Fledge, but not for industrial, specialized for industrial applications, but for most of the applications. We'll look at that, right? So the point here is the Ajax Foundry and Fledge runs on top of Eve at the smart edge. Now at the edge stack, it runs on top of Acreno. So Acreno is a little bit more heavyweight than Eve. Has to be, right? Theoretically speaking. Okay. So now if you go back to this Ajax Foundry, so what we have done is we have understood what is Fledge. We have understood this more on the industrial application. What we have understood is Eve, which manages the edge hardware, servers, and devices and everything out here. Then you have Ajax Foundry, and that's what we are looking at now. What is Ajax Foundry again? It's again a platform, right? That's not more towards the smart edge. It's kind of sits in between the smart edge and the edge, but it's again for the industrial applications. Okay, it's more or less like a Fledge, but it's again for the industrial applications, but a little bit heavyweight than Fledge. But the bottom line is, if you look at this Ajax Foundry is a interoperable edge software platform interfacing with device, sensors, actuators, and other IoT objects that can be leveraged to support specific requirements for industrial IoT applications. And it has certain services, right? It has device services, takes care of device, core, support, and application services. All are built on, in the microservice architecture. Why you need this? Why you need this Fledge and why you need this Ajax Foundry? Because you need to collect all those data from the sensors and everywhere. And you can do with that data, you can transport it to the applications that I showed you in the diagram, like SCADA and every application, so that applications can actually do its job. That's what Ajax Foundry does, right? Because all these lower layers, what it has to do is it has to provide enough data so the top layers where the applications that you built can smartly do depending upon the use cases that you are adopting. And there will be minor differences between Fledge and Ajax Foundry. If you look at it into the details, when you do your own analysis, that will allow you to decide whether you're going to go with Fledge or you're going to go with Ajax Foundry based on your use cases. But at a very high level, the concept is that edge and Fledge basically are for industrial IoT applications at this edge level. Okay, now let's go to the openness. So it's again edge computing platform for managing the applications and network functions. So this is not industrial IoT based specialized entity. This is mostly for like network functions like SMF or websites and those kind of things, right? You can manage that using openness. Application functions, REST-based interface and everything, right? You can do it with openness, right? So that's what is here. Now, again, at this layer, you need to manage these things. So that's where you have this Acreno. Now, if you go down here, Acreno. Yeah, it's here. So it's a Kubernetes based software stack, pretty much, right? Which can allow you to manage the edge. It's a little bit lighter weight than the bigger orchestrators that you have at the core network, right? So that's what this Acreno is all about. Now let's go up again, one step in the right. This is your regional stuff, obviously the bigger data center. So you have number of hypervisors and number of technologies like DPDK, OVS, right, KVM and things like that, right? So these are different things that you use for different reasons to manage this particular cloud infrastructure. So let's quickly look at that here. KVM is your virtual machine. SEP is your storage solution, right? Because you need something to manage your storages as well, and you need a virtual switch to manage all the physical switches and also switch virtually. You need a virtual switch. Fast data project is basically for the acceleration, right? If some of the applications require, you cannot do all the processing at the user level, right? You got to do at the kernel level sometimes and also at the NIC level sometimes. So there's a number of technologies that are available, and one of the technologies is FDIO that allows you with the data plane acceleration. Then you also have a DPDK, which is also allow you with the data plane acceleration. What it does is it kind of allows you to skip the kernel if you're running it in the VM, right? And there is another thing called SRIOV, which you don't see, that will allow you to skip even the hypervisor to push the data directly from application, write it directly to the NIC. Okay, so these are all the different technologies that sits across. These are all some of the examples that they have put here, right? Now, what you have done is this whole thing that you learned so far from the open source, what you really try to achieve here is that this picture here, right? This whatever you learned theoretically at this level, right? This level, and same thing here, right? What you have learned so far is the practical open sources that are available to manage this highlighted level. Now what we are going to look at is that something that manages at this level. At this level, you need a virtual infrastructure manager, VNF manager, and service and resource orchestrator. That's what you need, right? Now, if you go back to this, that's what exactly it does. You need an SDN controller to manage the routing part of it, L1 and L2. And we already learned what is SDN controller. The open source are called Open Daylight. Tungsten Fabric can allow you to do that. In interest of time, I'll skip it, right? Then you have the infrastructure management level, right? The Vim level layer, and also at the VNF level layer, right? You need. So this one, Anukut OpenStack Kubernetes, is mostly the infrastructure management. ONAP is one that manages not only the VNFs, but also the resource and service orchestrator. So if you look at this, the why I'm trying to go through this is to kind of help you guys understand the barrier to entry is pretty much zero nowadays, right? And so much of softwares that are available, open sources that are available for you to build your own networks and services, from a simple network to a very complex networks. So only thing that you see here that is missing here is that OSS and BSS, this part of it, right? And even OSS and BSS, there are so many open sources that are out there. You can just go and Google it, right? So build run to the number of open sources that are available. And also some beautiful closed source like MyCloud BSS, Mr. Bhavin, right? So anyways, so I think you got my point. This is very, very critical that I wanted you guys to understand, and hopefully it kind of brings to a kind of an understanding of how this whole end-to-end thing works, right? This is very, very critical. Now I'm going to go one step further. Okay, I'll pause here. Most probably I will hijack today's session, but logically it will come to a conclusion. You would really love it when you try to get out of this session. But I just want to pause here and check. So far, are you able to understand whatever that I said? Do you have any specific questions? Was I too fast? Are you guys okay?
Yes, fine. Yeah.
Yeah, all okay, Karan, but I think, I think this stack is growing, and, putting all things together to make an end product, I think that's where the challenge will be.
Yeah, yeah. But you don't do that, right? In practical.
Yeah, correct.
It's a combination of multiple people. That's why you have this Linux Foundation networking blueprint team, no? That brings different people who have expertise in different layers to put this whole thing together. But what's important to understand is this is where the mindset of a developer and a solution person comes in, right? I keep saying developer is low in the level, right? You don't realize that, but when you grow up in your career, you will realize development is you do development when you're building an app, you do development when you're building a network function, you do development when you're doing testing, you do development when you're doing automation, orchestration, lifecycle management. Yeah? The development is the very basic level, okay? Then you actually get into the next level where you expand your knowledge, right, across the architectures of what you're building. Whether it's an IoT, it's the same thing, right? Whether it's an IoT, 5G, whether you're building a metaverse, whether you're building an app, whether you're building a SaaS, whether you're building a network as a service, all those things that we learned. The end-to-end picture, a person who builds or the one who runs the company, right? An entrepreneur or a senior leader within the company. So you go and look at all the senior leaders within the company. They are end-to-end picture guys, right? Not the focused people. The focused people, you still have, like, I have a friend who is almost like maybe much like 5-10 years experience than me. Even today he does coding, right? He builds the stuff. He's too narrow minded. You tell him what to do, then he does, right? He cannot really. So you have to grow up in the, you have to continue to be a developer, but you have to grow up in the ladder to understand the big picture. You need to put dirtier hands into solutions, testing, architecture, bringing different pieces together. You have to put your hands dirty. If you do not, you will never grow. Right? This is period. You will realize. If you don't realize now, you'll know. And like I told you, if there is a session where they are teaching you what is finance, what is profit, what is loss, what is balance sheet, go and learn. If there is if you get an opportunity to go and build a sensor, go and do. Right? If you wanted to write a firmware, go and do. If you wanted to do. So if you make yourself to go and do multiple things, the knowledge that you gain over the period of time is more valuable than you focus on doing one thing. If you don't understand what I mean, and if you're not convinced what I mean, just go by my word. You will realize what I'm saying in next 5 years to 10 years. So the more knowledge that you acquire from tech and non-tech knowledge is what will make you mature, right? So let's move forward. Okay, but you don't have to be a master, but you got to know. You got to make your hands dirty, right? I have worked on Tally tool, right? I have worked on non-tech related number of different tools. And I'm just an engineer, but I had like PhDs from different domains reporting it to me, right? Multiple PhDs. I know nothing compared to what they know, right? But if you know, it will help. I'll kind of pause here, right? If I start the storyline, it will continue. I just have another 15 minutes to close on this story flow. So now, it's that now you understood this 5G point of view. You got to also understand 5G is not only 5G, right? So 5G has multiple different technologies that you need to know to put these things together. So whatever that we studied before, right? You need to know hardware knowledge, you need to know embedded knowledge, you need to know automation and orchestration knowledge. Automation and orchestration lifecycle management is a testing pretty much, right? It's a testing and solutioning knowledge that also requires the development to build that. And then you have a IoT knowledge, sensors knowledge, SCADA knowledge at the edge, for edge. I kind of told you, right? If you get an opportunity in anywhere in working, just go and do, right? That's what will make you successful. Now, in that context, right? If I go one level above, mostly what we discussed is this level, right? And we also discussed about automation and so on. There are things that are also very important in addition to whatever that we have learned, right? The security is a big thing. You have to kind of understand what it is I'm not going to explain, but what it is, how the security play a role in this whole ecosystem. How do I secure the data center, cloud, private, public? How do I secure my application? How do I write a code that is secure that hackers cannot come in? How do I deploy the infrastructure where the ports are closed and the ports are open only that I wanted it to be open and when? I mean, if you just do some coding, if you don't know all these things, you won't get to the level where you wanted to be in your career growth, right? Security. Now let's go to the next one. Analytics and AI, big thing. Like I said, we moved from decentralized to centralized to decentralized to centralized to decentralized. Now, at previous time, there was no automation technologies that were available for you to really make this work. Now it is available. So analytics and AI is huge. Now, it's not about you make the network function, you make it run. So when you look at the new product development, the coming up with an idea, concept, and understanding the feasibility and doing the business case consumes 30 to 40% of your product lifecycle. After the product is launched, making sure the product is working fine, you're supporting your customers, understanding their additional requirements, and then going back to the concept, feasibility, and business case, the last part occupies another 40% of your product lifecycle management. The actual product development and testing is only 20%. If you look at the big picture. So do you want to be in 20%? Do you want to be in 100% from the knowledge point of view? Is something for you to decide, right? And only way that you can achieve is using two things, continuous learning. And the second thing is go and dirty your hands any opportunity you get. Don't block your mind. I want to do this. I want to do that. Those are all 30 years old, your grandfather times. You want to live in your grandfather times. You want to live in the future times. It's very important for you to decide, right? Okay. So this is what it is, right? You need to kind of understand OSS, BSS. We already talked about. OSS is making sure the network runs properly. BSS is making sure that you are able to have a good communication with your customers, bill him and get monies and things like that, right? Automation and orchestration is to make sure that the whole system works, including the network and the business systems. Assurance is very important, right? This is what is the post-tactical, monitoring the network and making sure everything is good, and then self-healing it, the network. This is very, very critical, assurance. Okay, now moving on, this slide I kind of already presented to you guys before, right? And I'm touching upon the same thing. The future networks is all about disaggregated, decentralized, distributed, automated networks, right? So the intelligence should be really high and it should be programmable. You should be able to identify if there is a problem. It should be all the security aspects should be covered. It should address, it is able to address all the applications that are demanded by the people. Low latency application, high throughput application. So how can you do that? The only way for you to do that is bringing new architecture to improve these. So from 4G to 5G, we brought in, right, a 10x almost, right, the traffic improvement in other areas. Now 5G to 6G, you have to bring in another 10x or 20x. And that is how you evolve in technology and you are able to offer different advanced use cases through your network, 8K video and so on, which is going to consume a lot of bandwidth. AR, VR games is going to consume a lot of bandwidth. Metaverse world is going to consume a lot of bandwidth. You need the network that can actually support that. That's why Facebook, after changing the name into Meta, they are working with Telefonica to establish this innovation lab to do that, research that, and how the future network has to be evolved to support these kind of complex use cases, which are bandwidth hungry, throughput hungry, low latency hungry applications, reliability hungry, security hungry applications. Right? So AI security is going to play a huge role. So now I want to jump into and just want to give you guys an introduction to the AI. So what is AI, right? The distributed, disaggregated, complex network, if you wanted to automate it and make it run self-healing and all those things, you need a artificial intelligence, right? So without that, you can't do. You just cannot do manual automations. It's not possible. Simply not possible. You know, if AI had not been there, again, you would have gone from decentralized to centralized, right? So the AI becomes a critical factor, right? To do any, not only the communications, right? Any networks, any deployments, any industries, whatever you're trying to do, AI is going to play a very, very important role. Now, AI is a broader concept. Okay. So what does AI means? How you can actually mimic the human, right? That's, I think that's definitions here, right? How do you enable the computers, right? Machines to mimic the human intelligence is what is all about the artificial intelligence. Now you can mimic that human intelligence in different levels, right? A very basic automation level to automatically make the machine to learn depending upon how while it is functioning, and it can go into further deep learning to think like human, right? So there are different levels and there are different algorithms that are available that allows you to do that. And I can get into explaining all those algorithms, but you can actually go to the Testoper YouTube. We have done a number of AI sessions. You will understand what I mean. But at a very high level, for wrapping up today's session, right, it's important that you understand artificial intelligence is going to play a huge role to run this distributed, disaggregated, decentralized network. And artificial intelligence happens at different levels. From normal artificial intelligence is a broader scope to the machine intelligence to the deep learning intelligence. Deep learning intelligence are the neural networks. It does multi layers. Nowadays, you might have heard, right? The speak recognition, image recognition. There are applications when it looks at your face, it tells you exactly your age. Okay, so those are the things, right? If you're in the industrial floor, if a robot is doing certain things, it keeps learning, and it improves by itself. Tesla car, right? It learns your behavior of your driving and it adapts to your behavior and it learns and helps you in driving. And it knows where you are making mistake and there it allows you to stop you making that mistake. Deep learning, right? So that's what the artificial intelligence is going to be. And it's a very key topic, even if you find an opportunity to go and work on artificial intelligence, do so. If you get an opportunity to get an opportunity to go and learn artificial intelligence at a high level, do so. You get an opportunity for service assurance, how things are tapped, how all these different messages are correlated, how the data is analyzed, how it is cleaned, how it is actually put it into perspective, what different types of models are applied into the data to really create that intelligence at different levels. Try to understand that. Then you become a better developer, better solution architect, right? So it's key. Moving on. So now I talked about networks, automations and orchestrations, assurance, AI, and all those kind of things. Now I wanted to introduce you what is Web 3.0 in a very simple way. So I probably used a number of times the word called decentralized, right? So the decentralized is always mapped to Web 3.0. I would have used the word disaggregated, distributed, right? Those are related to, again, Web 3.0, but those are related to as well how you build your applications as a microservices and deploy different things in different places like UPF closer to the user and etc., so that you can achieve your use case. So these three words should be like a mantra for you, right? Decentralized, disaggregated, distributed. This is where the world is moving forward. And I would have said this in multiple forums just to recollect you guys, right? Web 1.0 is all about the web provided you the information, you learned from it. Web 2.0 is all about you provided the information and others learned from it. And in Web 1.0, 2.0, the ownership was centralized. Facebook of the world, Google of the world, Amazon of the world became multi-billion-dollar companies. And they used our data, right, to monetize and make money. They used our location where we are to provide the location ads so they can make money. This is what happened in Web 1.0 and 2.0. And Web 3.0 is all about how you and me can make money. That is what the decentralization is all about. And in order for you to do the decentralization, one step further, there is a microservices. It is a microservice, and there is a concept called DApps, decentralized apps. How do I build the decentralized apps? Like browser is a centralized app. Chrome provided by Google. But how can I build a decentralized browser? Example, Brave. Storage, video and audio calls, operating system, social network, messaging, remote jobs. See, the new set of Web 3.0 or players are coming into this world. Right? So the Web 3.0 is all about how you and me can make money. If I am providing my health data for someone else to analyze and make money, why can't I make money based on my health data? If I am providing a location-based services, my location information to someone else who is making money, why can't I make money by giving my location to someone else? This is what the Web 3.0 is all about. Right? And mostly you're going to have a decentralized apps, decentralized browsers, and so on. The most important thing is no one centralized entity owns it. That is the most important thing of Web 3.0 technology. Now you might have heard about metaverse. What is metaverse again? Right? So it's again decentralized, disaggregated, distributed. There's number of technology. These are all the concepts, right? There are a number of technologies that will enable metaverse. But in general, the definition of the metaverse based on Metaverse Standard Forum is that it's the combination of Web 3.0, some immersiveness. What do you mean by immersiveness is you getting involved into the activities, right, in the digital world. And see, if you think about it, maybe some of you do games, right? There's like a lot of different games where you have your own avatar inside that games, like Decentraland, and you live in the digital world, you earn money. So you have two lives. One is your physical life, which you eat and live with your families and friends. And there is another life, which is a digital life. And so, some of these whoever is attending here, you probably are living in two life. But if you're not living in two life, then you are an old generation from that point of view. You look at your kids, they have two lives. I'll tell you, my son, right? He has a physical life with me and he has a digital life in his own digital world. In his game world, he has his own avatar and people know him by that avatar. And he earns NFTs and things like that from there. And he has his own presence there. So he lives two lives. If you think about it, right? So that's what is going to happen, right? That's what the immersiveness is all about. If you remember the slide that I talked to you about, bringing physical, digital, and human together is where the different products, platforms, and solutions are getting developed. This is another example to that. It's a combination of Web 3.0 technologies and the immersiveness is what is going to make you metaverse. And it has to be disaggregated, distributed, microservice based, DApps based. Decentralized. Ownership is not with one person, it is with us. In order to do that, this number of technologies is going to play a role. Now the technologies lines is blurring. If you cannot say, I want to be an expert of this technology, 5G technology, I want to be expert of AR, you can, right? But you need to know everything because all these things are coming together to make things happen. Whether it is a 3D content scanning, right? If you look at it today, diverse technologies will need to work together in a novel ways, deriving the need for constellation of interoperability standards. To build your use cases for metaverse, could be a 3D content, XR, real-time environment, scanning, design, streaming, geospatial, digital twin, IoT. There's different things that are going to come together to make things happen. Selling and buying the lands in the decentralized land real estate, right? You have a ownership in the physical world. You have an ownership in the virtual world. You're going to live two different worlds. And the advantage of living in the digital world is you can be what you are not in the physical world in the digital world. in the physical world, you will be like a thin person. In the digital world, you'll be like a Salman Khan, right? So there's number of things, right, that's happening, but it may be beyond our times, right, or beyond our thought process, but there are people living in this time already in one or other form, but it will continue to evolve. And that's what is going to make this Web 3.0 very interesting. And the use cases on metaverse, IoTs, industrialization, 5, everything is going to become very interesting moving forward, right? So if you look at metaverse again, right, I talked about multiple technologies, right? It's already 10 o'clock. Give me 5 minutes. I'm almost in the last slide, last 2 slides. So I talked to you about metaverse, right? As an example, different technologies going to come together. And I talked to you about Industry 4.0, different technologies are coming together to solve the problem. I talked about Business 2.0. I talked about Web 3.0. So if you think about it, the basic theme is that multiple different technologies are going to come together to solve your problems, solve the customer problems in the physical world, digital world, human world, or in the combination of all the 3 worlds, or in all the 3 worlds. Okay. So this is key for you to understand, right? And that's what this particular diagram is talking about, right? It's a collective virtual space created by the convergence of virtual enhanced physical and digital reality. So in the physical world, you have coins, right? The rupees and so on. In the digital world, you have cryptos, NFTs. And you're going to use all these different technologies to really get there. Okay, now moving on, that's all fine, right? We talked about blockchain, we talked about AI, we talked about number of things. How is it coming back and connecting to this 5G, 6G? How is it connecting to the future network? Go and look at Helium, go and look at Poland, go and look at Metablocks, go and look at Airwave. What are they doing? They are building a decentralized mobile networks. Not centralized mobile networks like Rogers, AT&T and all is doing. These are all decentralized mobile networks on the access side. I'm sure it is also going to evolve into multiple things moving forward, even on the transport fiber level as well. I'm confident, right? As things might evolve, right? It depends. But the point is, all the technologies that you learned, right? Centralized to decentralized, things are moving. What does it mean? What is the operating system for decentralized blockchain? How are you going to manage the decentralized with automation, AI, analytics? How are you going to bring the immersiveness into this? AR, VR, XR, MR. How are you going to build the 3D objects into it? How are you going to bring the spatial into it? How are you going to bring? This is how it is, right? The technologies is not about different technologies. It's about how are you going to use the technologies to really achieve what you wanted to achieve? How are you going to bring the hardware? How are you going to build the hardware to deploy these networks? So this is what I wanted to connect and give you guys input, right? And like this whole thing is going to get finished with the blockchain, right? The beginning of beginning. You might think I wanted to develop only 5G protocol stacks. If you don't know how you're going to connect it to a blockchain, I mean, you can't really be a future developer. If you don't know how to connect that to AR and VR, you cannot be a future developer. If you don't know how to connect that with the firmware and the hardware and other things, you cannot be a future developer. It's all connected. Understand this. A lot of people don't understand this. They think they are making the right decision, but that's not the case, right? Go and do your own research based on what I'm telling. You don't have to believe me what I'm saying. Go and do your research. Look at some of the developers who are successful and look at what they know compared to what you know. The developers who became CEOs and CTOs, look at what they know and what you don't know and what you need to do to become them. Then you will get the answer, whatever that I'm trying to explain here. Closing this whole presentation with the blockchain, the beginning of beginning, is because it is going to be your disaggregated, distributed, decentralized operating system by default. You can do all these things with blockchain, without blockchain. So without blockchain, if you do, naturally you are going to you're going towards a centralized direction. With blockchain, you're going to do it. You're going to go decentralized direction. So now what is the blockchain? It's very simple, right? It's a decentralized architecture, a framework, and infrastructure which allows you to deploy decentralized applications and store the data in a decentralized way securely. That is not tampered by anyone. How do you make sure it is not tampered by anyone? There are police sitting within the network called as miners. They validate all the time to make sure no data is tampered with some kind of consensus, which is called as proof of work. And nowadays there is so many proof of XXX. That is what this blockchain is all about. Blockchain is not cryptocurrency. Blockchain is a platform and applications are cryptocurrency. Helium is an application on top of blockchain platform, which provides the Helium tokens. Bitcoin is an application that sits on top of blockchain platform that provides crypto. Now you can have a private blockchain and public blockchain. Private blockchain is truly decentralized, owned by people. Private blockchain, it has all the benefits of the blockchain, but it is still owned by certain administrators. Controlled blockchain. So the blockchain is again a key concept into the world of Web 3.0 and the applications around that. Let it be Industry 4.0, Business 4.0, whatnot. So that brings to the closure of the technology aspect that we wanted to learn, right? And I'm very happy that at least I'm confident, and I'm also very happy that you guys by now, if not, you can always go back and look at all the records. Going through these 4 topics would have at least given you a big picture of different things. And my goal of going through these 4 sessions is to really help you guys to understand the big picture and start seeing the world differently than how you normally see, so you can become successful. This is very, very, very important. Okay, so the last session, which we are going to have next week, right? Yokesh, the plan for that session is let's have 4G and 5G, quick demo, right? Let's plan it for 15 minutes, 5 minutes for 4G and 5 minutes for 5G. And you also mentioned, Yokesh, you prepared something for 5PV6. Try to see if you can squeeze that into 5 minutes to 10 minutes maximum. So 20 minutes will be the technical session in the next one. And I will take probably 10 to 15 minutes in Spectrum. Then we will use 5 to 10 minutes to close the session and do a quick survey in our next session. So that will be the plan for our next session, so that you can work with Parthiban and you can prepare accordingly if you are okay with it.
Yes, sure. Sure.
Okay. So I will pause here, guys. Hopefully it was very useful. You learned something today.
Yeah,
Was it interesting, useful, guys?
Yeah.
Or was it going a little bit above the head?
No.
What about Shashi?
Yes, Kader, it was useful.
Yes, Kader, it was good.
Okay, Shakti?
Yeah, it was useful, Kader. Very nice session.
Yeah, so now what you need to do, guys, is take this and then start expanding around it, right? Try to understand. I'll give you one example, right? Try to take a world map and try to understand the whole world, which country is where and what is the capital. That's one way of doing it, so that you can plan your future travel. Or other way of doing it is just pick a country and say, hey, I'm going to go to this country and I'm going to see and come back, right? So it's about you looking at everything and understanding from all perspective and making a conscious decision for your vacation, less cost and more value for your money, versus just picking someone blindly and going there and get whatever you get from it and then coming back, right? That's what this life is all about, right? Understanding the big picture and doing things is a different viewpoint than just doing one thing. Just keep that in your mind. With that, let's close the session. Apologies, I kind of extended 9 more minutes for today, but I'm happy that I was able to share things that is going to help you guys with your future. So with that, let's close the call. Guys, have a wonderful day. evening, and see you in your in our last session in 2 weeks.
Thanks, Kader. Happy weekend.
Happy weekend.
Thanks,
Bye-bye.
Kader. Thanks, everyone.
Yeah, thank you.
Thanks, Kader. Thank you all.
Thank you.